Have you ever thought about what it would take to fly a drone on a different planet? Well, NASA has. It takes a lot of physics, it takes a lot of engineering, and it also takes getting a ride there. Well, they got the ride figured out. They put a drone in the bottom of the Perseverance rover. It's safely on the surface of Mars, driving around right now, looking for the perfect place to take off. Now, here on Earth, drone technology is coming along, but it all comes back to something just as simple as this, a basic helicopter. Now, a helicopter is a rotor vehicle. You've got the rotors on top, and as they spin, they create lift. Now, in our model, it only has one rotor, but most helicopters have two because you have to keep the whole craft from spinning out of control. So there's the main rotor that gives us lift and steers and drives the helicopter. Then in the back, there's a tail rotor. That's what keeps the whole helicopter from spinning out of control. Now ours, when we give the tail a pull, it comes apart and launches the upper rotor to send it into space. So drones here on Earth look pretty familiar nowadays. We've all probably seen one in the store or seen one on TV. We have our drone here at Exploration Place, and then it has 4 different rotors. Now, 2 rotors spin one direction, and these 2 rotors spin the other direction. That's what provides stability, and it allows us to steer. And then, of course, the rotors, all 4 rotors spinning, is what gives us lift and control of this, the Z-axis. Now, the coolest part about drones and technology today is the cameras. We've got a camera on the bottom of our drone that has 4K resolution. Now, sending a rover with a drone all the way to Mars would be worth nothing if we didn't have a cool camera on it. So the camera on the bottom of the drone that's on Mars is going to be the biggest tool that we use. Once it launches, it's going to be looking at the surroundings. It's going to be looking at the rocks, the terrain, and giving our rover new places to explore and giving our scientists here on Earth more information for their research. Our drone on Mars is a little bit different than our drones here on Earth. One, it had to be much more compact to fit on the rover, and then it also has to deploy itself. So as it deploys out of the bottom of the rover, it actually folds down and extends its legs, lands. Now the rover is made up of a few different parts. You can see here, we've got the legs of the rover, which have now extended. Then you've got the main body of the rover. That's what's going to have the camera and the navigation and all of that in it. Then you go up on the top and you've got 2 rotors. The 2 rotors are on top of each other, one over the other. You have a shaft that goes through the center that is able to drive the 2 rotors in opposite directions for stability, steering, and control. Altogether, this is the coolest thing I've seen happen in space for a really long time, because it's going to be the first non-manned powered flight on another planet. Think about it. This is some really cool stuff. All right, well, you don't have to be a rocket scientist to have a little bit of fun with helicopters at home. We've got a simple activity from nasa.gov. Basically, it starts like this. Take a piece of paper and some scissors. Make sure you have your parents' approval. And then you just cut a nice strip out of the paper, like so. Then we're going to take the scissors and be nice and safe and put them away. Now, we take our strip of paper and we fold it in half. Once it's folded, we're now going to fold down our wings, and we want to fold them so that they go opposite ways. So our first one folds like this, and we end up with like a 45-degree angle there. Now we're going to turn this one around, and we're going to fold it the opposite direction so that it goes in a 45-degree angle. And if we were to set it like this, you're going to see it like this. When we let it go, it goes like this. Then we take a paper clip and attach it to the bottom to give it a little bit of weight and hold it together, just like so. You could also attach a penny with some tape or something like that. You just want to give it a little bit of weight. We take this and we drop it. It's going to spin just like those seeds that come off of certain trees that allows them to travel a little bit of distance. This is going to do the same thing. Now at home, you can take this and try and hit a target, just like what NASA is going to be doing soon.